directly. So can you able to see this screen?
Yeah. I can see.
Okay. My sound is audible to you?
Yes, sorry.
Okay. So good evening. We are giving a ELV system design training here. Okay. So I have just given the introduction here for
Yeah.
your understanding what we do actually. I have
Bhaskar,
a
I will put myself in mute.
mute. Yeah.
Is that okay, or shall I
No,
continue?
it's fine. I just want to check with you that are you from the background of ELV system or what is the recommend for you? So based on that, I can brief you so I can change the way
Um,
of yeah telling you
Actually,
the
basically, I'm an electrical engineer. If you're working, I have experience around like 12 years.
okay.
Overall experience in UA, I have around 5 years working as a MEP engineer, MEP coordinator.
Great. Okay.
Uh, so I just want to get in depth of ELV. So I
Okay. That's
just
fine. That's fine. So yes, you can go ahead and you can mute yourself. And in case if you have any doubts, you can anytime can stop me and ask. Okay.
yeah.
Since it's introduction session, so you can have a just completely go through that. I
Mm-hmm.
believe you have gone, you are aware about the system, ELV system. So
Yeah.
I believe you not have much uh, details required for the basic level. Anyway, we can start the
Mm,
session now.
yeah.
Okay. So what we do is a ELV system design here, design calculation. So as you see, the ELV system is part of a MEP package. Okay. So what is the ELV system? Here, just I am for a brief for understanding. So it's not going with the low voltage. It's an extra low voltage system. As you see, it works on the very low voltage, 12 volt,
Mm,
24 volt, and 5 volt, or etc. It's the
yeah.
minimum voltage level the devices it takes. Okay. So the ELV systems, extra low voltage systems, is it's a part of MEP package, as you are aware about it. It's like we can say some of the example of the systems are access control, AV system, BMS. I think you are still your mic is not mute, Arun. Yeah. So type of the systems are the examples of the systems are access control, EAV system, BMS, CCTV, GMS, GRMS, lighting control system, and fire alarm system, public alarm, etc. So we can go through just in a brief of architecture of ELV system here and advantage of both of architectures we have. So basically the architectures are on-prem or cloud-based as you aware about it. So on-prem is like the complete setup comes in the local inside the community area or inside the compound of the project itself. Let's say for CCTV system, when we take a CCTV system, the complete server and everything comes inside the building or inside the premises where we work, and it doesn't connect with the outside world, and it doesn't store in outside the world. It's called on-prem. And if it's connected to the outside world and the storage is happening outside of the world, it's a cloud-based solution. Yeah. So we have divided the architecture based on the system, as we know that it's the technologies are moving to the cloud based, so people do not want to spend much on the local storage and the servers and maintenance for that, so everything will be cloud based. So the access control system, CCTV system, even BMS, IoT systems are coming in nowadays it's with cloud based. Yeah. So when we go with the type of architectures, we can say is IBS, Integrated Building Management System, PSAM, Physical Security Information Management System, and SMS, Security Management System. So these are the different type of names they call it as. So based on the purpose, it varies. So when we have a building management system and we are integrating with access control and CCTV, we call it as integrated building management system. When we purely focusing on the physical security, then the architecture and the software level and the access levels are various, and it's called as physical security information management system. Also, they call it a security management system for integrating access control and CCTV system. So we see that the advantage of the systems here in the next slides. So we have the technologies are evolving and systems are coming up with the new technologies. So as we are learning the system, we have to learn the latest technology as well to in order to make ourselves fit for this ELV system discipline. So we have to know the role of AI, IoT, cybersecurity, which is also a necessity here. So we will be sharing the slides and the latest regulations of cybersecurity and latest advantage in AI implementations in the different systems. Like we can go for the CCTV or access control or building automation system and IoT, Internet of Things. So mostly the sensors are coming with Internet of Things. When we go for the critical architecture, so in the plant area, it's communicating through IP using Internet of Things and storing in the cloud-based solutions. So these are the latest technologies evolving the ELV system. So here, this slide, just want to show that who has to learn the ELV package. So first thing comes the investor, it's money. So the people who invest. So it looks like a small package when we go in the big volume. So ELV package, the value is significantly getting high based on the technology what we are using and based on the proposal how the integrators are giving. So it's essential for the client representative to know about the ELV package, at least in the basic level, to evaluate, So because when the contractor bidding for the projects, so they consider as a very small package, okay, this is just we can quote. And later we can see that when we compare the one they awarded to the contractor, he considered very basic and other guy considered the latest technology innovation in the ELV system selection. So it's essential for the client representative to know at least a basic idea about the ELV system package. And the next comes the consultant, the evaluator. So since the evaluator, the consultant is drafting the specification for the project. So it's essential for the consultant to update his knowledge about the latest technology which is comes in the ELV system. So he has to update the specifications accordingly based on the client need, based on the latest technology, based on the local and the international authorities and regulations. The next comes the main contractor. So the main contractor, when we talk about the ELV package, it comes under the main contractor. So it's essential for the main contractor to understand the system, how it functions, and how it's affecting their delivery and how it's affecting their project way of approaching. So it's all depending on the ELV system packages as well. So since even it's a small packages part of a main contractor, so it's essential for the main contractor to appoint a guy who can know about the ELV package and who can verify what the integrators quote and whether compare it's in line with the specifications. So they are in between the consultant and the ELV contractor. So when we come to the MEP contractor, mostly the MEP contractor, it's part of a main contractor or it's a separate company. So this is where the ELV package comes. So the MEP contractor, it's a subdivision of the main contractor who handle the ELV system package. So it's essential for MEP contractor who has an engineer who's managing the ELV system in and out basis of the project implementation. So why it's like a ELV package? Because ELV package is not limited to electrical or plumbing. Also, it's going with the mechanical, electrical, and plumbing. When we talk it about building automation system, so building automation system is covering all the MEP. And when we talk about the CCTV system, yeah, it's covering electrical and it has to coordinate with the mechanical parts as well. So how they are implementing the CCTV surveillance system, where they are implementing the cameras, and where is the MEP rooms are there, whether we need to cover those areas. So it's all interrelated. So it's essential for the MEP contractor to know about the ELV package and appoint the engineer or the manager to manage the ELV package. Next comes the ELV specialist or ELV contractor or the solution provider who's part of MEP contractor who's providing the solution. So it's 100% the guy from ELV contractor's perspective. He should know about what he proposed. Not only as a single person or the complete team has to aware about the system so that they can effectively do their project implementation path and without any recurring mistakes or reworks. Apart from that, the graduate who has a passion to learn the new systems, let's say if they are completed the electrical triple in Bachelor of Engineering or BSc in electronics or something, so they want to start with their career and they are looking for where to start. And if they are very keen into this ELV package, they have a passion to do that, so they can learn the system. So these are the people who has to learn ELV system, and it's very much essential for the people who's involving in the construction field, since it's a growing field and it's a most demanding field in the construction market. So it's good for the people to learn ELV package. We can go to the next slide. So as I defined earlier, ELV system is part of MEP package. And when we talk about ELV package, there is a specification part of MEP. It's part of MEP specification, or if you can say specifically part of electrical specification, you will have a ELV tender spec as well. So the tender spec will define, have the detail about ELV system, what has to be proposed and what has to be designed and to in line with the client requirement and in line with the consultant requirement. So basically, the guy from ELV package solution provider, he must know the specification. He must understand the single line diagram provided by the consultant and the shop drawings if anything is there, or develop the shop drawing based on the IFC drawings and prepare the equipment schedule and follow the local guidelines, norms, or international standards. Like when we go for fire alarm system, know about NFPA 72 and 70. And when we talk about local guidelines for example, for the CCTV system in UAE, we have a CIRA regulation, ADMCC regulations. So this has to be followed. And when we are talking about BMS system, some level of ASHRAE standard has to be followed when we design for the ELV package for the BMS package, especially. And and we talk about whatever the things we have in the specifications and the drawings. We develop a shop drawing based on the IFC drawings, and it's very much essential for the team who's designing the ELV system in case of any loophole in the specification or unclear about the design what a consultant have given or the client have given to raise the RFI request for the information. Because when we the develop as a draft, so when the consultant make a draft, the implementation phase might be goes after 6 months or after a year. So by the time there are a lot of changes happens, or maybe there is architectural changes are there. So based on the architectural changes, there may be a design change will be there, or maybe there is regulation updates are there, local regulation. So the international regulations based on that, the the specification also might be outdated. So it's essential for whatever loophole, whatever it's not having a clarity to raise a RFI by the ELV design engineer. And apart from that, clarifying the scope with the contractor and consultant also, it's very much important to make the scope matrix and responsibility matrix, who do what and what is their scope of work. When we say, like, for example, we have a ELV contractor, it's our scope of his work is to implement the ELV package. There is no containment and there is no civil work involved. Then this should be very clearly specified, and demarcation line has to be mentioned in our single line diagram between the scope of work or the scope of work matrix, responsible matrix has to be defined. so that there should not be any scope creep happens during the implementation project. Okay. And apart from that, there is a important thing is for finding on the site survey, because when we talk about the specifications and the drawings, and when there is a site survey happening, so in when we go for the site survey, there are something differ and something it's not in line with the specifications happens. So it's important to go if you are going for any retrofit jobs. We go the site survey and find the things which is not in line with the specification, or there is a deviation from the specification or from the drawings, and highlight to the client and consultant. It's very much essential because it's ultimately the project cost also involving to win the ELV system packages. So that the responsibility of the ELV design engineer is to look at the requirement very clearly and to not to overcoat or not to undercoat. So both cases he will lose the job. So he will not win the project. So it's to ensure that we are in line with the client requirement. Any deviations are there or any confusion or loophole is there to raise the RFI and get clarified from the client and consultant. So this is just one simple architecture of PSIM system. So here we can see the surveillance monitoring and the servers, and we have a fire alarm system, CCTV, access control, intercom, PA system, all connected in a single network, and it can be monitored and controlled from a single software. So that there it comes a physical security information management system software. So this software, what it does, it's interlink all as a line of actions or the workflow can happen. Like for example, it's in case of fire happens, the same location, if any fire exit doors are there, to open the fire exit doors, the command has to be go to the access control system, and access control system door open status has to go back, and the same time the CCTV monitoring should be started to focus, and it should start to comes in the screen automatically pop up so that the people can see the intensity of the fire in that location, or the intercom system we can connect with if in case if someone is there to talk, or with the security guards to announce. So this is like a more or less with a physical security information management system architecture type. I have just put populate the subsystems here and monitoring. So we have a video wall. In the video wall, the pop-up will happen automatically based on the workflow what we defined, and it will be the crucial part is here when some security issues happens, like when fire happens or when someone tamper the door or some clash happens between the people, or some unidentified people comes to the premises, and it's some suspicious activities are happening. It's important to relate and integrate all the systems together so it function like a smoothly, and the effective action have taken within a short period. When the system is it's independent, so you need to spend a lot of time. The fire alarm system comes, then we the guy has to look the CCTV system. There is a different operator from CCTV, and he has to look the access control. The different workstation is there. He has to look the access control workstation. So it's a lot of works when we have a individual standalone system which is not integrated. Separate systems are there. So this we understand the physical security information management system requirement in critical infrastructures, or where the client feel that it's more essential for him. Here, a small standalone system architecture we talk about here. It's not connecting to the outside world, and like a CCTV system, we have a workstation connected with our intruder alarm system, our fire alarm system. It connected individually. There is no connection with outside world. Here, like a small architecture of server and hot standby server. So in case of failover, hot by standby server is here. In case of failure of the server, the data are not lost and still it's taken over by hot standby. and we have a workstations and the client workstation separately based on the system wise, or the multiple systems can be merged also from the client. The other another one example is like it's multiple compounds. Let's say like servers for individual compounds for individual systems are to group together, and you will have a one central location or standby server. So if the server in one location failure, the other server take over. So it's one of the architecture, so which is to avoid any data loss or critical activities. So hot standby servers we have in the central location. So here we can just a brief about the access control system. So you know about the access control system here, like this is all about who's accessing the door and what time and which door. That's all about access control system. It's not big philosophy on this. So very simple way is the guy is accessing. So accessing which door? Okay, what time? These are the informations as content by access control system, and these are the things are controlled by the access control system. In the design criteria, when we talk about, so we have to choose the server and licensing art standby server, cloud-based solutions. So these are the different varieties of the technologies we have in the access control system. When we talk about it's again it's on-prem or the cloud-based solutions we have, and you will have standalone server for the on-prem, and you can have a standalone server with a art standby server for the failover, or the cloud-based solutions that you do not have any architecture in the local premises, and all stored in the different location in as a cloud-based solutions, and you have to have a yearly subscription has to be paid. And it's also again the licensing you need to consider. So when you choose for the doors, how many reader licensing you need to consider, like 12 readers, 24 readers. So it's not to overcode or undercode based on the number of readers. We need to choose the reader licensing, as well as the server also. So the server also you have to choose based on the type of the software you required. Let's say the software set defined professional, enterprise level, and corporate level. So professional is for the basic one, and for the enterprise level you will have, on the corporate level you will have. It's a different functionalities are there, and capacity also differs. So you have to choose the software based on the type number of the doors, and also you have to choose the reader licensing based on the number of readers you have in the building. Okay, and the selection of controls also, you have a master slave concepts, and you will have IP based. So when we have to check the specifications, in the specifications, sometimes it's asked for master slave concept, and somewhere they look for only IP based solutions. So we have to choose based on the specifications. Either we can go master slave based, like master slave concept is like the master is IP based controller, slaves are RS485. It's a chain, it's a bus technology. You can loop from master to slave, multiple slaves. Okay, when we go with IP based, all the controllers should be IP based. It's clear? Hello?
Yeah, clear.
Just a moment. Hello?
Yeah, Bhaskar, we can hear. You can proceed.
Yeah. So this is how the access control system, when we are as a designer, when we choose, we have to look for the software and the reader licensing. And if it's a cloud-based yearly subscription, we have to choose. And when we choose the controllers, we have to choose the controllers Whether it's on-prem based, then there is a different types. You have a master slave concept or IP based. And when we go for cloud based, you have a cloud based controller need to be chosen. And apart from that, IO board for input and outputs. If you want to connect any external inputs, like for if you want to control the lifts and you want to monitor the lifts, so the lift status and the lift every floor lift control as input and outputs part of the IO board, and intrusion system if you want to connect with, or CCTV system you want to connect with. So we need the IO board for that. So this is how the selection of the controller happens. And apart from the readers, so readers also has to be chosen by the ELV system designer based on the client requirements, where you need RFID reader or where you need RFID plus keypad for the pin, or where we need RFID plus face. So the different technologies are there. So where based on the client requirement and based on the regulations, you need to choose the readers. Corrective readers has to be chosen. It's part of the ELV system designer. And I mentioned here, like you can see the type of the protocol it communicate with the controller. So the ACS reader have a vegan based. So vegan is a protocol, or OSDP is a protocol. So you have a Bluetooth communication between the device, like from the mobile, you can communicate with the reader or the mobile wallet. So these are the latest technology. And low frequency, high frequency, ultra high frequency cards also comes with. So based on that, like when we are going for vehicle access control system, we are using UHF cards so that the distance of the UHF cards are higher. We can say like 5 meter, 3 meter. When we go for low frequency readers, low frequency cards will be used. That is for feet, 1 feet or 1.5 feet, only the distance. It doesn't goes for more than that. So application based, location based, we need to choose the readers and along with the cards as well. And the card technology also, you will have a different type of card technology. MyFair, Desfire cards are there, and I-class cards from HID. So choosing the cards when we are going for the retrofit job, we have to choose not only the reader and the controllers, all has to be based on the existing cards, what type of cards they are using. So it's categorized, like when we go for retrofit, you have to check the existing setup and the existing cards, and choose the reader and choose the controller based on that. And the cables part, when we go with the cable parts, you have to look for the specifications. It's a PE based, PE jacket based, or low smoke zero halogen. So if you are quoting for a PVC jacket for outdoor, it's not correct way, because when we have outdoor, you have a PE jacket cables has to be considered. And if the client is looking for low smoke zero halogen critical area, critical buildings you are to working for the access control system, you need to go for low smoke zero halogen. So based on that, the prices also varies. So you have to choose the cables based on the specifications and based on the applications, based on the place where you are using. That is very much important. And when we go for the lock type, it's one of the crucial element in the access control system, because when we choose the locks has to be chosen based on the type of the doors and the functionality of the door and door ironmongery set. So we have a different type of locks. So magnetic locks, just you will keep it in the top of the door. It will have the armature element. When it touches, that magnetic field is enabled and it's holding the door. Or the strike lock, mortise lock. Mortise lock is part of the door itself. Door, it's embedded in the doors. So it will have the trim to open and close. Or push bar we have to consider for the staircase doors. So, and wireless locks where you go for retrofit jobs where the client is doesn't have a facility to make a containment, or you will have glass doors. So there you want to look for the wireless lock. You have to consider wireless locks, or the drop bolt. You have to consider where is the doors which is doesn't go with the magnetic lock. We cannot use the mortise lock. We have to go with the drop bolt. That is for example, for the glass doors. So based on the type of the doors and based on the ironmongery set, we have to choose the locks. So ironmongery set will be developed by the door supplier. It's a part of the MEP package. Whoever is supplying the door, they will come with the ironmongery set. So based on the ironmongery set, we have to choose the locks. That is very important as well because we cannot consider everywhere the magnetic locks or everywhere the mortise locks or push bars may be required in the staircase. If you don't consider, it will it will be add-on cost after we win the project, and it will go from our margin. So when we choose the access control system, we have to check for the fire alarm system. There will be a life safety requirement in the project or based on the international guidelines, which has to be followed, like for all the fire exit doors. So fire exit doors has to be integrated to open in case of any emergency. Automatically, all the doors locks has to be disabled to open in case of fire occurs or in case of any emergency. So this all has to be complied with when we are designing for the system. Like we have to choose the relays or any kind of interposed relay, any kind of integration required with the fire alarm system software level or hardware level. So those also costs are involved. So if we do not consider during the design stage, it will go from our margin when we win the project. So integration with the intercom system also it's essential. Like when fire happens or someone for example for the entry gates we have intercom system. Someone press the uh, some pedestrians are coming who's not authorized or who's new here like visitors they come they want to enter they press the intercom and it communicates with the intercom system and if the intercom system is integrated with access control system it opens the door automatically like once it's confirmed by the control room they can disable the lock power to open the door for the pedestrians. So like this kind of integrations are essential when we are designing the system. Apart from that, we need to connect the CCTV BMS system if it's a required part of the specification or part of the client requirement. And if when we do not have integrations, we need to look for the SDK software development kit or API interface for integrating the system if the integration is not already established. For example, we have access control system from one manufacturer and CCTV from another manufacturer. You want to do the integrations and the integration level has to be defined by the consultant. So we have to follow that integration level and we need to get a confirmation from both parties for we have to share the SDKs between the both parties to integrate, make the integration happen if the client or consultant looks for. When we talk about building management system, so all the building management system, what it does, it's like it monitors and control the different MEP equipments. When we say MEP, it's mechanical, electrical, and plumbing equipments. So we follow the client requirements. Apart from that, local and international building standards has to be considered as well while doing the design. So in the design criteria, we will develop a IO point schedule based on the MEP system, what we are interface with. Like for example, hair handling unit, the fan coil unit, booster pump, transfer pump, chilled water, like multiple systems, and you have a crack unit for IT rooms. It will be connected through the backnet or Modbus interface. So when we design the system, when we list out the equipments which we need to monitor and control, we need to define the interface also, whether it's a hardware interface or it's a software. When we talk about crack unit, it can be integrated with BACnet or Modbus. It will not have any hardware, uh, hardware input output apart from only giving the command. So the client is looking for the complete parameters to be monitored. So we have to look for the specification on the single line diagram. If it's not there, we have to raise the RFI and get clarified and need to consider in our IO point schedule. Like for VAV boxes, it may go from Modbus or MP bus protocol, and electrical DB might be electrical DB. We have a monitoring through PMU. If the client is looking for monitoring the electrical DB from the building management system or the water BTU, meter integration from M-bus. So these are the systems has to be listed out and put in the IO point schedule and define the interface and consider the gateways when we go for the MP bus or Modbus integrations or meters we are connecting through the MPUS and or for the lighting control system we are connecting through DALI digital addressable lighting interface or facade control system from DMX. So there are interfaces, there are gateways. So because it's a different protocol, when we are designing for the building management system, we have a system which is communicating through we can say loan works or it's from backnet and our Modbus. There are different standards are there, different protocols. And apart from that, if you are integrating the systems with the different protocols, it need to talk between each other. Since it's different protocols, it will not talk each other. We need someone to mediate between. That is a gateway. So when we are having a Modbus, you have a backnet, you need to have a Modbus gateway to speak to backnet. So the gateway will communicate. It will translate from Modbus to backnet to Modbus. So selection of server and licensing, again, it's based on the number of IO points. IO points, we can say that it's a software IO points or the hardware IO points. Hardware IO points, we can say its hardware points are analog input and analog output, digital input and digital outputs. When we go for the software, we will have a software inputs like software monitoring points, software control points you have. In that itself, you will have analog points and digital points. So you need to choose the servers and the licensing based on the IO points and the type of IO points. Cumulatively, how many analog inputs, how many analog outputs are there, how many Modbus points are there. So all has to be defined in the IO points, and based on that, the licensing on the server has to be chosen. So when we select the DDC controllers and IO modules. So DDC or direct digital controllers are having inbuilt IO points. Apart from that, some brands comes with the expanding IO modules or it's a fixed IO modules. So based on the specification may limit, okay, one DDC controller or one DDC panel should have a maximum of 50 IO points. Then we need to limit our design with 50 points. If more than that, we need to consider additional DDC panels. And selection of field equipments when it comes, we have to select the field equipments based on the system what we are what we are monitoring and controlling. When we go for AHUs, so we might have the control schematic received from the client. If it's not there, we need to propose based on the understanding from there, whether we need to monitor the temperature before temperature of the water in and water out, chilled water in and chilled water out, or we need to monitor the CO2 level in the duct. When we go for the car parking, maybe we need to monitor the CO. So all the sensors has to be chosen based on the client requirement, based on the control schematic, and based on the IO point schedule. So this is also very essential because when we missed out this sensors, then it goes from our cost. So choosing the sensors and listing out and making approval from the consultant before we placing the order. In case if any changes are there in the sensor type or the sensor signal type has to be revised and get the approval prior to placing the order. So the design what we do, it should be in line and we get approval before proceeding with the project implementations. So it's a crucial part for the design team to ensure that he get the approval before the project team start with implementation. So when we talk about the SCADA system, so supervisory control data acquisition system, when we go with, so the system, it monitors the complete building management system, whatever they integrated with. So we have to choose based on the capacity of the data points. So it also varies enterprise level, corporate level, or the basic SCADA system. So based on the type of the SCADA system the manufacturer has, it will have a different capability, whether it has to connect with the outside world or it's an on-prem solution only. There is no outside world connectivity is there on web-based application or the desktop-based applications. So we need to choose the application also based on the client requirement and specifications. And again, for the cables, we need to choose the cables based on the input output. When we are going with the sensor cable has to be screened. So when we have digital outputs can be unscreened, and jacket of the cable has to be chosen based on its application, its outdoor application or indoor application, whether the client is looking for low smoke zero halogen. Again, the last point is the integration part. When we are integrating the BMS system with the others, access control, CCTV, GRMS, or some other systems, what kind of integration is required? It's a hardware level or software level. If it's hardware level, only the hardware points has to be considered, like integrating the status of the NVR. For example, when we are talking about CCTV, NVR status we can get from NVR as a digital input for the BMS system, or for the GRMS, we have integration level to know the status of the rooms, like guest rooms. Any in case of any failure in the controller, it can be given the information in the hardware level or the software level. Same it's with access control system in case of controller failure or the battery failure, or in case if someone has opened the access control panel, and it can be given the alarm to the building management system. So it's depending on the level of integration level of other systems and the client requirement. Again, the design has to be chosen based on that. So the other system in the brief is CCTV system. CCTV system is all about the surveillance system. So surveillance system is basically for the security purpose of the buildings, to have a smooth function of the business functions of the buildings. We need to have a security systems in place, and it's as you see that it's the criteria is based on, we can say that the target distance and the specification, what kind of things we need to achieve from the view, and the light availability also. If there is no light, we need to consider IR. So it's beyond the beyond the human high level, because when the crime happens, you know that the crime happens most of the times in the dark place. So the dark place, the human naked eyes cannot be seen easily the picture or the scene. So it's beyond the level the CCTV cameras has to be designed. So it's all depending on the light availability also has to be chosen. If there is no light available, we have to choose the IR cameras. And the cameras also have defined in the different level, like we can say analog cameras or IP based cameras. So analog cameras are designed with coaxial cables and DVR, digital video recording, and IP cameras are IP based. As you nowadays, it's the cameras are coming with IP based, and most of the local regulations or international regulations also changing with IP based solutions only. So analog is now it's in fading away from the market. And then we are choosing the IP cameras. We have to choose the cameras, whether fixed lens cameras or varifocal cameras. If you know the area and the area coverage, you can go with the fixed level. And if the area is not defined, or if it's not clear area, you might go with the varifocal, or the specification asked for the varifocal, you need to go with the varifocal. And also type of the camera, you have a bundle dome cameras, so the housing is not in the way it's easily breakable. So mostly when we place the cameras for identification purpose, we need to choose the bundle dome cameras or the bullet cameras for the perimeter coverage. So it's all based on the regulations. So when we are designing for the system, we need to consider the local regulations and international regulations. Most of the Gulf countries have their local regulations. So the local regulations has to be followed strictly while doing the design. Apart from that, there is operational requirements are there. For example, if the client is the for example, the Dubai regulation is asking for 2 megapixel cameras, and the client want 5 megapixel cameras, and you want to record in 5 megapixel. So you cannot go and argue with 5 megapixel cameras why we need to give. If the client you get a if you get a clarification from the client, okay, we need to go with 5 megapixel cameras. So it's straightforward that we need to choose the 5 megapixel camera. We cannot go with 2 megapixel cameras. Even though you are complying with the local authority regulations that you are giving 2 megapixel cameras, some certain areas like there is a frequent movements when we go for the malls, or there are a lot of movements is happening in the complete field of view. The client may go with 5 megapixel or 8 megapixel to have a more detail in the field of view, or more detail in the video which is captured by the camera. So mostly the cameras are covert type. So covert type means it's open to the people, public, or the occupant who can see the cameras. It's straightforward, like it's not covered. So if you are having a overt cameras covered, so which is not allowed. As a special case, if you are having that kind of hidden cameras, you need to get approval from the clients for maybe some sensitivity areas to have the cameras in. Otherwise, you have to go with the covert cameras. So camera housing also you need to choose based on indoor based or outdoor based. You can go with IP50, 55 for indoor rate, but we have to go with IP65 or IP66 rating for outdoor cameras. So all has to be followed as per the specifications, as per the local regulations, as well as the international regulations. The selection of the recording devices, as we go with the DVR for the analog cameras with the coaxial cables. And when we go with IP, you can go with the NVR or NAS or SAN based or cloud based solutions. When we go with NVR, the devices having a storage and all together as a single unit comes. And NAS storage is like a network area storage. It has the server plus storage it comes. SAN is a storage area network. It's like from the name you can understand it's a storage area network. It's a separate area itself. You'll have a multiple storage devices and you'll have a controller to handle this all the storage devices. Or you can go with the cloud storage. It's the latest technology.
Hmm.
And some client is looking for, they do not want to have a local
என்னடா
storage. For example,
டேய்
when we have a,
டேய் டேய் இங்க வாடா டேய்
multi-region clients,
என்ன பச்சை
you will have offices in Dubai, he is having offices in Saudi, he is having office in Europe, and you want to do all storage from in from Europe place, then we will have a cloud-based solutions. So cloud, there are cloud provisions are there from AWS or Amazon or Azure or something else. So it's depending on the client requirement. If the cloud based, again the cloud based, he has to give yearly subscription fee, and there are charges are there, and he will have a let's say deck for the local server based and maintenance of the local server. Yes, the client, the maintenance guy has to go and check if in case of any failure is happening. And also storage bandwidth also it's reduced when we go for the cloud based. You do not require to have a separate room and separate cooling for that, and separate conduiting cabling, the infrastructure for this local based storage, like we are going with the NVR, DVR, NAS or SAN compared to the cloud storage. So there are pros and cons. So when we choose, it has to be chosen based on the client requirement. If client is really interested to go with cloud based. So also apart from that, we need to choose the video walls and controller for the video wall in depending on the authority requirement, and depending on like you choose the monitor is 24/7 monitor has to be chosen. Workstation, when we choose, you have to follow the manufacturer recommendations. Apart from the switches also, when we choose the switches, we have to look for the bandwidth, the switches, the bandwidth of the total storage data transfer from the cameras to the server might be it goes even more than 1 gig. We need to consider the 10 gig uplink switches, and cabinets, racks based on the devices. So we have to choose the racks, 42U racks or 27U, 19U racks based on the level of equipments which is storage inside. So we have to design the racks and choose the racks based on what are the devices are there, how many use it's occupy inside. So you have to choose that. Apart from that, there is a PoE long mid span is required when it's beyond the limit of 100 meter as a standard. So the cameras, when we go with IP based, it limit with 100 meter, like in the practical is 90 meter, and you will have a patch cord. So it will not go more than 100 meter, and the client also will reject. So that cases we might require to have a PoE long or mid span. It's like it extend beyond the 100 meter, or the media converter. You can convert from copper, means a Cat 6 cable, to fiber cable. It can go more than 100 meters, 300 meters, 500 meters, like that, based on the client approval. Apart from that, the critical structures, you may need to go with solar-based solutions, or hybrid power solutions, like it's mixed of solar and well as the electrical power for the plants and the critical infrastructure areas. And also when we are choosing the power source, the UPS also has to be considered. There is a regulations also asking like it has to have a 30 minutes battery backup. So we have to choose how many switches are there for connecting the cameras. What is the load of the switch? So based on the switch load, we need to consider the additional 20% spare based on the local regulations. If it's 20% spare or 30% spare. So if it's a local regulation, again it's asking for 20 percentage, but client is asking for 30 percentage spare, or if the local regulations is asking for 30 minutes and client is asking for 1 hour battery backup. So you have to choose based on the higher requirement always. So if you are the lower requirement, you will be losing. When we win the project, you will be losing from your margin. Okay, it's very essential that choosing based on the specification, local regulations. Apart from local regulations, operational requirements. If you want operational requirements is higher than the local regulations, consider the operational requirements in the higher level. So this is just a brief about CCTV, BMS, access control, and all ELV system as introduction. So that's all from my side for this the small presentation about introduction to ELV system. If anyone has the doubts, uh, please let me know. You can unmute your mics and can speak here.
Yes, hi.
Hi.
I have a doubt in this access control. I just want to know what is this fail safe and fail secure locks? Can
Okay. So when we go with there are locks defined fail secure and fail safe in the name itself. You can see that. So some of the doors are fail secure in case of fire, should not open. For example, I will say that one small example of the exit doors. So exit doors are fail safe doors. It has to be open in case of fire. Yeah, it should not be hidden. It should not be closed, because during the evacuation process, during the emergency situation, the people has to go out. So those doors are fail safe doors. And when fail secure doors, for example, we can say admin office doors. It has access control system, or IDF doors. It has access control system. So during the evacuation, during the fire situation, the people has to go with to exit, not to enter the admin room, or not to enter the IDF room, or not to enter some kind of officer room, or we can say manager room. You understand, right? So it has to be secured. It has to be closed. So fail secure doors has to be closed when during the emergency situation, and fail safe doors has to be open during the emergency situation. You got it, Abhi? Hello?
Yes, I got it. Yes, thank you.
Yeah. So it will be the evacuation procedure or the life safety system during the fire alarm system supplier or the client who will define which are the doors are fail safe and fail secure doors. You got it? So it's not defined by the ELV package ELV solution provider. It's defined by the consultant. The consultant will give that doors, and it has to be configured. And wherever the fail safe doors are there, there should be a fire alarm interpost relay will be there. So that fire alarm interpost relay has to be connected with the access control system. to activate to open the doors.
Okay. Yeah.
Like a zone-wise alarms will be zone-wise, there will be interposed a zone-wise alarm will be given to the access control system. So in case of any, like for example, if fire occurs, not all the doors open, right? Not all the exit doors. Where that's why we are defining in the fire alarm system as a compartment or the zones. When we are defining the compartment or zones, when the fire occurs, there will be a sequence. Okay, the within that fire zone, within the fire compartment, whatever the fail-safe doors has to be open so the people can evacuate. It's like a big architecture. Not all the doors has to open, right?
Mhm.
If